What's up, guys? I decided to record this just because it's briefer. No need to everybody get a meeting. Plus, it's Friday. I'll be quick. So just watch that first video. It'll just kind of run through a bunch of the reactions until you kind of just be able to classify them. Combustion, synthesis, decomp, so on and so forth. But one that I would really want to talk about is called single replacement because we're going to teach you how to predict the products. A couple things before we kind of get going on the backside of your periodic table. This is for single replacement, this activity series, and this is for double, this one right here, the solubility table. So we're going to talk about two different types of reactions, how to predict them. So the activity series is for single, this is for double. What we need to do is to be able to predict a single replacement. So what we're saying is that this is a solid, and then that this is a solution, AQ. And basically how we need to determine if this happens or not is the solid metal has to be higher than the metal that's paired. If it is higher, it'll switch with it. It'll kick it out. So what I do is I go back to my periodic table and I look and I find, what was it, sodium? That's the metal. Is it higher than copper? It is higher than copper. Okay, so it is higher than copper down here. So if the lone metal is higher, it's basically saying I'm cooler than you. I'm kicking you out of solution because I want to be in solution. So then what we do then is we just write the charges by each element. If that holds true, if it's yes, if it's higher, write the charges by each element. Switch the positives. So I'm going to say copper goes by itself, sodium, and chlorine then. Okay, and then kind of the rule of thumb is bring one of every element. Bring one of every element. Even though there's two here, there's one there. That's okay. We'll balance it out. So what I need to do then is make sure that the charges over here, +1, -1, are canceled. Okay, make sure those equal to 0 when you make a new compound. And then so that's balanced. Make sure the charges balance with subscripts. And the last thing is balance with coefficients, the big numbers. So I got 1 and 1, 1 and 1, and 2 and 1. So then I need a 2 there, and then I would need a 2 over there. So that 5-step process is kind of the gist. I'll do another one here. Magnesium higher than copper. Well, magnesium, the solid, is higher than copper. It will switch. Okay, so it'll switch. The answer to that one is yes. I'm going to write the charges by each element. +2. This is +2 because each nitrate is -1, so that's -2 overall then. I'm going to switch the positives. Mg, and then remember, just bring one of, and that's a polyatomic, so it's a package, one NO3 plus Cu. Okay, write the charges on the other side, +2 -1 +2, and then make sure these cancel out. 2. Okay, now I'm good. Check that. Don't have to worry about this one because it's by itself. And then balance the equation with coefficients. 1 and 1, 1 and 1, 2 and 2. I'm done. Okay. Now, what does a single replacement actually look like? Here's an example. Basically, what we're saying here is aluminum and copper chloride. So aluminum is higher than copper 2 chloride. That's aluminum. That is copper chloride. And then what happens is you can see the copper is kicking, or the aluminum is kicking the copper out of solution, and we are forming copper on the aluminum foil. So the aluminum's going in, you can see it dropping in into the solution. Copper chloride is a blue solution, and it'll end up being clear. Copper is brown when it comes out of solution. So as this progresses, you can see that we got a lot of copper forming and all the aluminum is dissolving. So that's a single replacement. Reactions are a lot bigger than, or metals that are bigger or on the chart, higher on the chart, will replace the ones that are lower. And if you look at the chart, just kind of some practicality things, metals that we wear on our body, like silver and gold, are not very reactive. They don't react with, they won't replace anything. If I had a solid gold ring, uh, it won't react with much. We hope it doesn't, because we wear it on our skin. If you won't want it to react with any of the solutions in your skin. You know that if you have like a cheap ring and like it leaves like a tarnished green mark on your finger, that it's higher. It's like a copper and tin and then like fool's gold type stuff that leaves like a green tarnish on your finger. So that would ultimately say that it's reacting with the solutions in your skin. So that's single replacements. Okay, double replacements. Now, what we need to do is we need to understand what aqueous is. So aqueous, if I put salt in water, what it's going to do is the water molecules are going to come in and they're going to break this apart, and basically you're going to have ions floating in the water. Nice rubber ducky. They disassociate. So for this, we can use the backside of our periodic table too for the solubility table. Soluble, the word soluble means it can dissolve in water. Insoluble means it won't dissolve in water. Now there's some exceptions too. So like carbonates, you see carbonates in your water at home a lot, on your like glasses and stuff that you wash in the dishwasher. Like calcium carbonate would be an insoluble compound, okay, because it's not a group 1 metal. By group 1 and group 2, we strictly mean this: group 1, group 2, okay, and then there's some other exceptions for that as well, for each compound. So basically, when you want to see if something is soluble or insoluble, all you have to do is just check the backside of the table, and usually we look at the anion, the negative part. Halides are just fluorine, chlorine, bromine, iodine. That's group 17, and then so on and so forth. So here's kind of what double replacement. It's like single, it's exact same thing, but all we're going to do is we're going to switch 2 of them now. For a double replacement reaction to actually happen, you have 2 solutions, and what's going to happen is you're going to have one solution on the other end and a solid formed on the other. So you can see here that the positive switch, and I go to NaCl and then CuOH. Copper hydroxide is what we call the soluble, or excuse me, insoluble. Insoluble means that it's a solid. This would be soluble. Okay, that would mean that it's soluble as a solution. Now, how do I do it? Same things as we did before. Okay, you got the charges, switch them. You have to really do the whole problem before you find out if the reaction happened. So in this instance, I'm going to switch the positives: NaSO4 and then CaCl. The positives always come first. Okay, so I'm going to make sure the charges cancel out. After I wrote the charges here, I'm going to make sure the charges cancel out. It's going to be, so it's NaCl plus CaSO4 goes to NaSO4 plus CaCl. So we wrote the charges: +1 -1 plus, my gosh, +2 -2, +1 -2, +2 -1. So cross the charges. I need 2 of those and I need 2 of those, okay, just to balance out the charges. And then now, before I balance the whole thing, what I can do is I can check these to make sure I can check this solubility chart and see if anything is. So for the first one, SO4, let's see if find SO4. SO4 is soluble. Okay, so that means soluble means that it's AQ, except with calcium, barium, strontium, blah, blah, blah. Okay, so I had sodium, and then so that would say this problem, this one right here, is aqueous. Okay, let's check out this one, chlorine. Chlorine, soluble, so that's AQ, okay, Well, soluble is AQ. Chlorine, well, okay, so that one's AQ as well. So basically what you can say here is that if you have two aqueous solutions, you got a no reaction. Basically, it's like adding water to water. So all that equals no reaction, no RXN. Okay, I'll do one here quick. Yeah, like I said, if both products are soluble, there's no reaction occurs. You just write no reaction. You need, for a reaction to occur, you need one product to be solid. All right. I'll show this demo here after I do it. Okay, so write the charges. So +1, -1, +2, -1. Switch them. NaCl. Bring one of each. Plus CuOH. +1, -1. That one's good. Oh shoot. +2, -1. So I need two of those. Okay, so I cross the charges there. Are they soluble or insoluble? Let's find out on our chart. It was chlorine, sodium chloride. Okay, chlorine's, that's soluble, that's AQ, and then OH is right here, insoluble except with group 1, and then we don't have that. Copper is not a group 1 metal. So then what I can say then is I can say that this is the aqueous solution, and this is a solid solution. So that's our, we call that a precipitate. It forms out. Now, here's the reaction, what it actually looks like. Well, kind of. It's copper sulfate. Just imagine that it's copper hydroxide. Okay. There's two solutions. You're going to mix it. And when you mix them, you get a solid in the middle. So you get a solid, and then the aqueous layer then is also what we call sodium chloride. So that's what a demonstration would look like as far as mixing two solutions and you get a solid. You could filter that out. You could put it through filter paper, and that's that. So moral of the story is make sure you just follow this process every time. Switch, charge, balance, and there's your rules for that. Okay. Here's your worksheet. This is just classifying. All you have to do is write single, whatever, and so on and so forth. And then here's just two predicting problems. Don't worry about the net ionic piece on the worksheet. All right, guys, love you lots. Have a good day. Have a great weekend. Touch base. Look for directions on the rest of the Google Classroom for Friday. And fill out the attendance form. Whoop, whoop.